Hey, good afternoon, good evening, good night, anytime you are watching this. This is paper 4 Geography IGCSE. Just to quickly do something to help the students as they prepare for IGCSE paper 4 exam in the next 4 days. Okay, so this is 2019 4-3, 2019 May June, variant 4-3. So let's just look at it together. So this question here, students in Greece were studying how different types of wave affected beach. So this is something on a post. So they wanted to arrange those words into the boxes there. So put the following feature into this. So waves are getting close together. For the destructive waves, waves are close together and waves plunges downward as it breaks. Waves are close together and waves plunges downward as it breaks. While for constructive waves, it will be waves are far apart and waves spills forward as it breaks. Waves are far apart and waves spills forward as it breaks. So just put the two each. So if you get all the four correct, that's 2 marks, But if you get two correct, that's just 1 mark. So let's run. I don't want to make this video too long so that you can watch it. You can watch it over and over and over again. Be careful. So describe the method the student will use to measure the frequency to get the results shown in table 1.1 inserts. So let's go to the inserts and see what they are saying. Table 1.1. Okay. Arcagelos Beach. So they measure wave frequency and the Afandome Beach. So what are the methods they could use? Of course, they can use a stopwatch to time, and they can count the number of waves breaking. As the waves come, they count the number of times the waves are breaking within a minute. And you do after 1 minute, you count again. So then you don't take the average of your reading. So you can do this on both beaches, Archangelos Beach and Afandos Beach. So you can do for both, see waves per minute. So the number of times it goes is 12, 13, and all of that. So that is a method. If you're able to get 3 clear statements, 3 clear sentences, that will be 3 marks for that question. That will be 3 marks for that question. If you get 2 right, that's 2 marks. Now, this question says the student researched typical beach profiles produced by destructive and constructive waves. And these are shown in figure 1.2 insert. So let's go to the figure 1.2 insert. Okay, profile shaped by the destructive waves. So this is the profile shaped by destructive waves. Then profile shaped by constructive waves. Of course, if you remember what beach profile is. So this is a ridge. So this is a constructive wave because it's building the beach. A destructive wave is eroding the beach. Now let's see what the question is quickly. Describe the method shown. So is that not the one we just did? Okay, wait. Okay, the student decided to investigate their following hypothesis by doing field work at Afando and Ancello Beach. So that's the hypothesis there for you. So students have learned that destructive waves and constructive waves vary in their frequency, as shown below. So from here, 10 to 15 waves per minute, while constructive wave is 6 to 9 waves per minute. Now describe a method the student will use to measure the wave frequency to get the result. That's the one we did now. Yes. So the student researched typical beach profiles and produced by destructive and constructive waves. So a destructive wave destroys the beach, it erodes the beach, while a constructive wave builds the beach. Let's settle that. So this figure 1.3 insert show a method of measuring the beach profile. Describe the method shown. So they want you to describe, so you create a transect line from the sea. So a transect line is just like, measuring that from here, maybe something like from here to here is where you are going to do the thing, is where you're going to do your measurements. So create a transect line or line from the sea to the back of the beach. So from here to here, that could be where you are going to work on. Then put poles at each break of slope. So you can put a pole here. You can decide that, oh, let that be one pole here. Let that be another pole here. You can put another, just at the, at each slope end, so that you are going to measure the angles of the poles. So measure the pole. So you put some angle there like that. Same length above surface at each point. So the pole must be of the same length. Then use a clinometer. A clinometer is something used to measure angle. So you have to put a clinometer somewhere there. You can watch a video to know how a clinometer is used. So put a clinometer to measure the angle. So that will give you the angle of each of those points. Then you can repeat this along the transect, or you can just hold the clinometer at an agreed angles to read at other points. So you will put the clinometer here, put the clinometer here, put the clinometer here, and record the angles. So you do the same thing along this beach as well. So you do the same thing along the beach. Okay, fine. So let's go on. Let me clean this. Okay. Let me. So the students use their measurement to draw the profile of at their Fandu beach. So this is when they finished, this is what they got based on the angles and the distance. So they got something like this, which they plotted. So what conclusion would the student make? Hypothesis one, at Afadu beach, the peak profile is produced by constructive waves. Yeah, I think that is correct. Hypothesis is true. As you can see, that this looks like a constructive beach. Look at it, you can see the shape is building up. So the hypothesis is true. Apadu beach profile is produced by constructive waves. As you can see, the average wave frequency per minute is 7.3. That's if you go back and check the table that we checked earlier in the here for this table for Afadu beach 7.3, while here is 13.2 for destructive waves. And if we go back and check this, it's kind of the average of this is more or less like that. He said we support evidence from table 1.1, 1.2, and figure 1.4. Which figure is this one? This is 1.4. So what evidence is here? The shape Look at the shape. The shape is like that of, if you look at it, it's closer to that constructive wave. Then from here is 7.3. That's the average frequency. Where is that? Okay, look at the shape. It's just like this. And the, what's it called? The, then with that figure that we got. Now, to investigate hypothesis 2, beach material is larger at beach formed by constructive waves. The student then obtained a sample of pebbles from both beaches. Describe a method they could use to get reliable samples in order to compare them. So what are the methods that they could use to get, so they can measure pebbles, they can measure along the beach tracé line. They can do systematic samplings. They can select pebbles at equal intervals. So basically, this is sampling they are going to use here, and they are going to do that at regular intervals, equal number of paces. Then any method any sampling they use here, if it's random sampling, they have to decide, pick at random or systematic sampling, or what's the other sampling? Systematic, random, and what's that other one? So whichever one they do, they will pick at different sites and decide the distance apart from the pebbles, so they can pick up pebbles. So they have to note the distance you are picking those pebbles. That is, they must be aware of the distance. Describe a method to measure the size of the pebbles. So they can use a pebblemeter. A pebblemeter is an instrument used to measure the width of a pebble. Or they can use a vernier caliper. You can just Google it online, what a vernier caliper is. It's just like it looks like, what's this thing called again? Clipper, just like a clipper. It clips the pebble and you can measure the width. Basically, it's to measure the width. So it's the width that we use to decide the sizes. So a vernier caliper is used to clip each pebble and you record the width, or a pebblemeter. Or alternatively, you can use a ruler. You can use a ruler to do it. So the result of the student field work are shown in table 1.2, table 1.5 and 1.6, page 7 of figure 8. So this one, they want you to conclude it. On figure 1.6, draw the bar to show the length of the pebble number is. Pebble number 1 is 8.5. So this one is just pebble number 1 on page 1.6 on the graph figure 1.6. So which is, okay, this is figure 1.6. So you come here and just draw it. Let me try and use this. So let me use a black. Okay, yours better than this. 8.5. So where would that stop? Let me see. It has to be a straight line. On my own, it's just, let me clean it and draw it properly. So it should be something well done. Let me use this line. This line is better. 8.5 is, let me see. This is 8. and 8.4, 8.8, 9.2, 9.6, 10. So 8.4, so 9, 8.4, this 8.4. So I think we should get this middle line. So you can just make sure you draw it well. Where am I going to? Sorry about that. Make sure you shade it well. This freehand thing is not easy. You are doing paper, so that is what you are supposed to do. So shade it and make it look like that. And make sure you did your scaling right. That's the most important thing. Your scaling should be okay. That's what they are going to be interested in. The shading is not as important as the scaling. Okay, so let's move on. What conclusion will the student make about hypothesis 2? Which material is larger and which is formed by constructive waves? Support your decision with evidence from figure 1.5, 1.6. Well, the hypothesis will be false. Let's first and foremost look at this 1.6. Let's see which material is larger and which is formed by constructive waves. We can see that like here now, at the Ajello Beach, average pebble size is 10.3, median size is 9.5, which is more than 7.3, which is for the constructive waves. So that is just one. Then if you go and check other, you see that beach materials are larger at beach formed by destructive waves. If you go and check with the average size of this, you can see that it's different. Then if you check like I showed you the average of that. Well, actually, then table 1.1, let's check table 1.1. Okay, table 1.1 is just telling us that anything of this average is, no, sorry. Actually, at Afandu Beach, the average size is smaller than the wave frequency, and the wave frequency is lower. While at Ajelagilo Beach, the average size is larger. And if the average size is larger, that means the destructive waves. If the average size is larger, that means it's a destructive waves. Let me move on. Students plan additional piece of work to investigate longshore drift to the area. Describe and explain the process of longshore drift. Well, a longshore drift is a process by which beach waves move materials at zigzag. You know, materials are moved across the beach. You can watch a video on it. Swash brings the material to the beach. Swash, what is swash? Swash is the water that comes from the beach to the coast. So it brings some materials, while backwash takes them back at right angle. So swash brings the material at angle. It brings it at angle. Backwash takes it back at right angle. Swash takes it again at angle. Backwash returns it. Swash takes it. Backwash returns it. So this zigzag movement, imagine some materials were here, now they are here. So that is long short drift. This is the diagram they wanted to show, but you have to explain it and still show the diagram. So the movement of materials across the beach in a zigzag manner. That is long short drift. Okay, describe a fieldwork method to show that the just use. They want us to do a project, a kind of how it will be done. Yes, you can paint your stones. You can paint it in different colors so that when they are moving, you can check them. So paint some pebbles, put them at the post, then monitor their movement. You can measure the line, you can measure the coast to know the exact length you want them to cover. Then you can put a hole, in a where you are starting from. Then maybe put a hole where you want them to stop. Then put them in a swash, backwash zones where waves break, so that you can be noting, you can be following it. Then leave them for a period of time and just watch. Then after some time, track the distance moved and get the average, something like that. I believe that should suffice to explain it, kind of. So I believe that's just, I've done one for you. That one is 4 marks. If you were able to get it done quickly. Students in UK did some field work to compare two residential area of inner city, divided the investigation into two parts. First, they studied the environment of the area. Second, they investigated what people who live in the area thought about their quality of life. Now, let me just go to the question. To investigate hypothesis one, the student observed some features of the local environment at one side of the area. They recorded their results on the form shown on figure 2.2 insert. So we'll go and check that. So what's the first question here? Before they began their field work, the student went with their teacher to practice their survey in the area near the school. So suggest two reasons why they did a practice survey. Because that's like a demo. So they need to do that to learn how to do survey, to agree with what the description means, and to learn what will work and what will not work in that area. Just to familiarize with the area and get to have some first-hand experience of how things will look like. It's just like trying to do just to dummy and see what are the likely challenges we are going to encounter, and as well to learn about each other, how to work with one another. Okay, so anyone you give will be fine. Explain how the students will organize and carry out their fieldwork using, carry their fieldwork survey using the form shown, the figure 2.2. Okay, let's see what the form looks like.